Can we make architecture like we make cars through an efficient industrialized process?
If you really explore the manufacturing process of these other types of products, you'll see that it's a very efficient and streamlined process. You begin with components that are shipped to an assembly line, and the final product is assembled.
At Virginia Tech, researchers at the Center for Design Research are exploring innovative ways to utilize up-to-date manufacturing techniques for the making of architecture.
You take these precast elements, you stack them together, and because they're modular, they're a perfect fit.
By prefabricating the more complex components of a building, such as kitchens, bathrooms, laundry rooms, and mechanical closets as cartridges, the research team has discovered an ideal method to deliver modular housing.
What we're doing is taking an approach to building a building in a factory. The way we're proposing a kitchen is to build it as a cartridge, just to build it as a standalone component.
The FutureHAUS kitchen is proof of concept for this cartridge idea. The cartridge assembly begins with a hollow frame made from structural wall panels. Since these are all cut using the CNC process, precision in assembly is guaranteed.
So we used structurally insulated panels, which are SIPs, to kind of house the whole kitchen and keep all the super high-tech equipment safe for transport.
The frame becomes an ideal site for installing the kitchen with plumb walls and level floors.
This is the perfectly manufactured box.
The aspect of building a kitchen at a time versus a cabinet at a time, for us, would have very little impact. It would be easy to do in this factory setting. We also barcode all of our components and jobs so that we can track a kitchen throughout our process. There you go, there's a great example of your drawer head, a nice white 3-coat catalyzed white varnish, white paint. And that's a drawer front to your sink base and your range base.
Yep. So that's the very first piece of the kitchen of the future, right here.
At the cabinetry manufacturer, the kitchen is installed in its structural frame, ideally as the next step in the assembly line process of the cabinet making. Cabinets, appliances, plumbing, electrical, and electronics are all installed by skilled tradesmen in optimal working conditions. In addition to the cabinetry, all dimensional materials in the project are cut with a CNC process, including the panelized walls and glass countertops. This guarantees the precision required for any modular system to work.
As the years changed and the digital age came and the internet came about, we've seen a lot of changes. AutoCAD came into the picture, CNC came into the picture. We've seen digital printing come about, and that's kind of where we're at today. Yes, now we'll cut things to exact size, locations, the pattern will be exact within a thousandth of an inch, and then we print on that glass too. And the printing would be just like, again, as you took a photo of yourself, we can print that photo exactly to a piece of glass, and it'll be there permanent.
Okay, now this kitchen is installed. You bring in the plumbers, you bring in the electricians, you install your kitchen, you bring in your IT guys. They install the smart technology, and then that kitchen can be wrapped up and delivered to the assembly line.
This cartridge concept allows Virginia Tech to propose the Internet of Things kitchen, where every device can receive and send information.
What it means that each object, each appliance, each cabinet can be a thing with internet address, can be connected, can talk to other devices, other things on the internet. And so now what we have that lower level infrastructure that allow us to collect data constantly. The data can be accumulated and used for various purposes.
All of our cabinets are touch to open, easy to use, easy to access. They've got LED lights throughout for convenience. Here you can see the virtual window. It's the 3 horizontal displays that have an integrated frame system that converts them into multi-touch. Because all of the components are together, they can now start talking with each other. They can start being integrated with each other. This concept could be utilized for a single-family home, or it could be utilized for mass production housing. Right now, we're focused on the design and development of a whole city block.
Eventually, the FutureHAUS team will install a 2-level prototype on campus to demonstrate the many innovations of their off-site construction process. The team will explore modular construction methods including module stackability, structural connections, building enclosure details, energy-efficient systems, and affordable housing. Through their research, the Virginia Tech team hopes to verify the many benefits of off-site modular construction.
What we're making, or where we're researching, is a whole new idea for how you build.